Hello, Namaskar, Khammagani people. My name is Nandita Sudha Tiwari and welcome back to our channel, that is Professor Tiwari. In our last lecture, we talked about thermodynamics from class 11th physics, and today we will going to move further in the same topic. So our today's topic will be about thermodynamical processes. Thermodynamical processes. So what does thermodynamical processes mean? In order to understand it, you first need to revise what we have learned in our previous lectures. For example, thermodynamical processes means that it is happening or it is occurring in a system. What kind of a system? The system should be thermodynamical system. So the first point is thermodynamic system. Let's just say thermodynamic system. So we first need a thermodynamic system in order to talk about thermodynamical processes. So what is thermodynamical system? Thermodynamical system is basically a system. For example, let's just understand it by an example. You have a container or a cylinder. You have a container or a cylinder, and in this container, let's just say this is a rigid container, and in this container there can be any substance like gas, liquid, solid, or combination of any two of these, or combination of any three of these, sorry. So for example, let's just say that we have molecules of gas, or this container is filled with gas molecules. Okay, now is this a thermodynamical system? Yes, it is a thermodynamical system. But this thermodynamical system, in order to define this system, we need to talk about certain parameters. For example, if I say that define this thermodynamical system, in order to define thermodynamical system, you need to have some kind of information beforehand. Now, what kind of information? For example, if I ask you to introduce me with your friend, or to tell me about your friend, let's just say your friend name is Neha. So in order to introduce your friend, you can talk about her name, or you can talk about her pros and cons, what kind of nature she is. For example, she's kind, she's introvert, she's extrovert, she's helpful, she is studious, or she is smart. So these are what? These are all traits of a human being which basically define a person. When we talk about the thermodynamical system, you cannot say that the system, if I ask you to define the system, you cannot say that the system is kind, helpful, or studious, because all these traits are human nature. But in order to define this thermodynamical system, we need certain parameters, or we talk about certain parameters. Now, what are these parameters? See, in this case, first of all, we do not say that only define the thermodynamical system. We will going to use a more jargon word. So basically, we speak about the state of a system. If I say define the thermodynamical system, that means I am saying you what is the state of a thermodynamical system. I am asking what is the state of thermodynamical system. So this is the first thing. If I am saying define the thermodynamical system, that means I am asking what is the state of this thermodynamical system. By state, I only mean what is the nature of the system, or what is the behavior of system. That's the same thing. Now, to define the state of this thermodynamical system, there are certain macroscopic state variables, or you can also say macroscopic parameters, or thermodynamical state variables. What are these? In order to speak about the state of thermodynamical system, there are certain parameters, and these parameters are known as macroscopic state variables, or you can also say thermodynamical state variables, or parameters. If you have information of macroscopic variables or thermodynamic state variables, then you can speak about, or you can tell about what kind of nature or what kind of state this thermodynamical system has. Now, what are these macroscopic variables? These macroscopic variables are pressure, volume, temperature. These three are the main which we will going to study in this syllabus. There are few more, for example, mass, composition, internal energy. It is defined by U, and entropy too. But as I said, we will not be talking about entropy, though it is a macroscopic state variables which is helpful in defining the system. But in this syllabus of class 11th physics in thermodynamics chapter, we are not going to get introduced by the entropy word, so we will not going to talk about it. The main thermodynamic state variables that we will be using will be pressure, volume, temperature, mass and composition, and internal energy, which we will going to study in the later topics. Now, if you have information about the pressure of the system, the volume of the system, the temperature of the system, mass and composition, we already know before even starting the experiment. Let's say if there is a gas, let's just say there is a nitrogen gas, so you know that what amount of nitrogen gas you have taken for your experiment, so you are aware about the mass of, for example, mass is universal. For nitrogen mass, it is universal, so you have idea about mass of the nitrogen. If you are taking mixture of different gases, that means you also have the idea about the composition of the gas or liquid or solid inside it. But we need to talk about the pressure, volume, temperature and internal energy. If you can speak about these parameters, these macroscopic state parameters, that means you can define this particular system. Now, this system is nothing but assembly of extremely large number of molecules, particles or atoms. These are all what? Gaseous molecules. So they are assembly, means these molecules are like they are together. When particles or something is together, particle or atoms or molecules are together, we just use the word assembly for it. So this is the thermodynamical system, which is basically get defined by the macroscopic state variables. Now the system can also be in equilibrium. What is the condition for this system to be in equilibrium? We need to first understand what does thermodynamical equilibrium is basically. See, because these parameters define this thermodynamical system, so if these parameters do not change with respect to time, for example, this is the gas and this is the cylinder, and let's just say that all these walls of the cylinder or the container, let's just say these walls can be diathermic means conducting in nature, or these walls can be adiabatic means what? Adiabatic means perfectly insulating in nature, that means nothing can pass from it. So let's just say that if these walls are diathermic in nature, that means conducting in nature, so easily the gas inside this container can be affected by the surroundings, by the external factors, because we know that the temperature outside is quite higher than the temperature inside. So all these parameters can get affected if the walls are of diathermic nature or of conducting nature. That's the first point. So in order to consider the system in equilibrium, or to put the system in thermodynamic equilibrium, we need to see if these parameters are changing with respect to time. Okay, we have already learned all these topics in our previous lecture, but I am just repeating it because from last 1 year I was not able to make the videos. So that's why I thought that before starting with the new topic, it would be better if we just go through with few of the important topics which we have already done. Now, see, this is the thermodynamical system. We were talking about thermodynamical processes. What does thermodynamical processes? These processes take place in a thermodynamical system when these parameters get changed. When macroscopic parameters get changed, then we say that there is a certain kind of thermodynamical process is happening. So what are these processes? Let me first rub all these things. So that there are total 4 type of processes that we will be studying in our syllabus, out of which 2 processes are important, which we will going to study in detail, and the rest 2 are not that important, but we will still going to see what does these processes mean. Okay, so thermodynamic system and thermodynamic processes. As I said, thermodynamic process can only occur if the parameters or if the macroscopic parameters of this particular system will going to change. Now it depends what kind of parameter is changing. According to that, the type of process will going to occur. For example, the first type of thermodynamical process is isothermal process. The first type of process is isothermal process. Now again, as I always say that before starting any topic, if you really need to understand, if you really want to study a topic, you should first know that what does the word itself mean, so that you do not need to cram the topic. Okay, so what does isothermal process mean? See, iso basically is a Greek word. As we know, most of the words in science is basically originated from Greek words. So iso, the word iso means same or equal, same or equal, and we know that the word thermal means temperature. That means in isothermal process, we have already understood that in isothermal process, the temperature will going to remain constant or same or equal. So in this particular type of process, temperature remains constant. Temperature remains constant in isothermal process. If I say temperature remain constant, then what left? That means the other parameters will going to change. What are the other parameters? We have just seen them. The other parameters are pressure, volume, temperature, mass, composition, and internal energy. Okay, so if the temperature will be constant, if this temperature will remain constant in this particular type of process, that means there will be a change in pressure and there will be a change in volume. We cannot change the mass. As I said, mass and composition are always fixed, so you cannot change them. Means if you are already running an experiment, you cannot change composition. You can decide it before the experiment, like what kind of mixture of gases you are taking. But once you have started the experiment, or once you have started studying a particular container or a thermodynamical system, then you cannot change its composition after that. So mass and composition will always be constant. Your internal energy, we are not considering it for today's topic, but in later topics we will going to talk about internal energy as well. So what we are saying, in isothermal process, if temperature is constant, that means there will be change in pressure and volume. Okay, now what is the example of isothermal process? The very good or the fantastic example of isothermal process is refrigerator. What it is? Refrigerator. Refrigerator is one of the example of isothermal process. How? See, there are many changes that take place, a set of changes that take place in the mechanism of a refrigerator. We will be learning about the working of refrigerator in our later topics. Of course, it is in the syllabus, but as of today, refrigerator, what happens in a refrigerator is lot of changes take place in its mechanism. But one thing that remains constant is the temperature inside the refrigerator. By constant, I am not saying zero. Sometimes people think that constant means zero. Constant doesn't mean zero. Constant means same or equal or at some fixed point. So the temperature inside the refrigerator always remains constant. But other things, yes, of course, do get changed, but the temperature never gets changed. What basically a refrigerator do? The function of refrigerator is it removes the heat from the materials that we put inside the refrigerator, and then it transmits that heat to the surrounding. That's how it is maintaining its constant temperature. So what important thing we are learning about the refrigerator, that in refrigerator temperature always remains constant, or it maintains the constant temperature by removing the heat from the material we put inside the refrigerator and transmitting that heat to the surrounding. Surrounding means our house or the environment. Okay, this is how it is maintaining the constant temperature. Now the second example of isothermal process is heat pump. The second example is heat pump. It is also a kind of a refrigerator. Their functionality is quite same, but what happens in heat pump is either it removes the heat from your house or from your room and dump it outside or to the surrounding, or it brings the heat inside your house to keep your house warm. So basically it is keeping your house cool and it is also keeping your house warm. It depends. Okay, many times people get confused that heat pump and AC are same, but they are not same. Heat pump and AC are not same. Why? We use AC in summers and we use heaters in winters. So basically if you need to understand, then heat pump can do functionality of AC and heaters all together. One device can do function of both heating and cooling. But AC, that means through heat pump, it has the capability to remove the heat from your house and to also bring the heat to your house in order to keep the house warm. But AC cannot do that. AC is only good for cooling. So heat pump and AC are not same, and if you want to understand the difference between heat pump and AC, then you can go and read about the literature. And if you want to make me a video, I can do it once I will be I will finish the chapter, of course, which is already very late. Anyways, so the next process is, this is all about isothermal process. Now the next process is, we will be learning or studying this process in a very detailed manner in our coming lectures, because this process and the next process which I will be discussing now they are given in detail in your syllabus, and the rest two are in brief. Okay, so the next process is adiabatic process. The next process is adiabatic process. What does adiabatic process mean? As I said, adiabatic, I just said that adiabatic means insulating in nature. That means nothing can pass from it. And because we are studying thermodynamics, that means we are talking about temperature and heat in specific. That means it is a type of a process where heat cannot enter or exit the thermodynamical system while the process is going on. In this process, free exchange of heat is not possible. Heat cannot enter the system and heat cannot exit the system once the system is already in the process. So this is adiabatic process. What is the example of adiabatic process? Example of adiabatic process is your ice box. Ice box, which most of the people use in their house, where we put water in order to convert it into an ice form. So what is the function of ice box? In ice box too, the same function happen, or the adiabatic process happen. Once the process is going on, the heat cannot enter in the ice box and the heat cannot even leave the ice box. That's why you always find ice in a similar way. If, for example, if heat would be coming and going out from the ice box, then you would have never seen, you would have never be in the position to see ice. That's about adiabatic process. So the only thing that you need to remember is that heat exchange between the system and the surrounding is not possible. This is the system and the rest of the part is the surrounding. So heat exchange is not possible in adiabatic process. We will be discussing this adiabatic process in a lot detail in the coming lectures. Okay, so the next process is, the third process is isobaric process. Okay, so what is isobaric process? Again, iso means same and baric means baric, it is all about pressure. So isobaric means same pressure or constant, same pressure or constant pressure. So that means pressure remains constant in this process. In order to say that the system is going through with the isobaric process, you need to see whether the temperature of the system is constant and not. So if the pressure is constant for the system and we are saying that the system is undergoing the isobaric process, that means the other parameters are getting changed. If pressure is constant, then definitely the volume and the temperature of that system should be changing. Okay, so now what's the example of isobaric process? Example of isobaric process is boiling of water. Boiling of water to steam, and the second example is freezing of water to, let's just say, ice, whatever it is. So these are the two examples of isobaric process. How boiling of water to steam is a isobaric process? See, first of all, most of the people think boiling of water to steam is evaporation. Boiling of water to steam is not evaporation. This process, boiling of water to steam, is known as vaporization. This process is known as vaporization. And if you have seen one of those lecture about superfluid and about the triple point, I have already discussed these topics: vaporization, evaporation, condensation, sublimation, crystallization. So boiling of water to steam is not evaporation, it is vaporization. And in evaporation, boiling never takes place. Evaporation is without boiling. Vaporization is with boiling. Basically, what's the difference between evaporation and vaporization? Though there are a lot of difference, one of the common difference is vaporization is that process in which water boils at a particular temperature and it gets converted into steam or vapor or a gaseous form. But that particular temperature is not, common. That the particular temperature is the critical temperature or the boiling point. And what is the boiling point of water? Boiling point of water is 100 degrees Celsius. Boiling point of water is 100 degrees Celsius, or you can say 212 degree Fahrenheit. See, so this is that temperature at which water gets converted into steam, vapor or gaseous form. That's the reason it is called vaporization. And what is evaporation? Evaporation also means that some amount of water is getting converted into vapors or in gaseous form, but it always happens below this temperature. Below boiling point, evaporation happens, and it never happens for the whole of the amount of the water. It always happens for some of the layer. We can discuss vaporization and evaporation too in detail. I will be making one video about the difference between vaporization, evaporation, and also the boiling. Boiling and evaporation are also different. Basically, vaporization are of two types. One is evaporation and one is boiling. So you can say that vaporization is the parent process, and then comes the evaporation and boiling. Okay. We will going to talk about vaporization and evaporation in detail in our further lecture. But for today, anyways, now the next example is freezing of water to ice. Freezing of water to ice. Again, this process is what this process is. This process is known as condensation. So even if you want your water to get converted into ice, there is a particular temperature for this. Water freezes at what temperature? Water freezes at 0 degree Celsius, or in Fahrenheit you can come, it is 32 degree Fahrenheit. So on this particular temperature only condensation process occurs, or you can say when the water will be at 0 degrees Celsius, then only it will going to get converted into ice. This is a particular temperature. Okay, so these are the example of isobaric. Okay, why it is isobaric? Because when water boils and converts into steam, or when water freezes at 0 degrees Celsius and converts into ice, in both of these processes, either the gas will be compressed or the gas will be expanded. So when the gas get compressed and expand through these two processes of compression and expansion only, you can keep your pressure constant. So in order to keep the system's pressure constant, you need to do the compression and expansion process, and that you will going to do with the help of temperature, definitely by keeping your substance on a particular temperature called the boiling point or the freezing point. That's the difference. Okay, now the last process is, we will not be studying isobaric process in detail, though I will be defining it little bit more than your syllabus, but we will not be studying them in detail as compared to adiabatic process and isothermal process, because they are not part of the syllabus. Now the next process is, the last process is isochoric or isovolumic. Isochoric or isovolumic process. Isochoric or isovolumic process, as the name says, that means volume remains constant. That means in this type of system or in this type of process, volume remains constant. Volume remains constant, that means other parameters will going to change. If volume going to remain constant, that means there will be change in pressure and there will be change in temperature. Pressure and temperature in this particular type of process will going to get changed and the volume will be constant. Now in order to bring your system under the effect of isovolumic process, you need to keep the volume constant. What is the example of isochoric or isovolumic process? The example is pressure cooker. Its example is pressure cooker. How pressure cooker is an example of isovolumic? Because you need to see that either this particular object has to keep its volume constant. See, you have a pressure cooker, for example. There is a sealed closed pressure cooker. That means volume cannot get changed now. If the pressure cooker is open, that's a different thing. But once the pressure cooker is sealed closed, that means you cannot change the volume of this pressure cooker. Now, if you put this pressure cooker on a flame and gives this pressure cooker a heat, that means the air inside the pressure cooker, the temperature and the pressure of that particular air inside the pressure cooker will going to increase rapidly. What I am saying, let's just say this is a pressure cooker. Okay, this is a pressure cooker. I'm not good at drawing, so sorry for it. Let's just say this is the pressure cooker and you have nothing inside it, but just you have set it free. That means there is air only in it. Now, if you once the pressure cooker is sealed closed, that means its volume cannot get changed. Now, if you put this pressure cooker on a flame, once you put this pressure cooker on a flame, there will be change in two parameters. The air inside this pressure cooker will gonna get the air inside this pressure cooker, its temperature and pressure will going to rise rapidly, so that there will be increase in temperature and there will be increase in pressure once you put that pressure cooker on a flame. Now, because the temperature is constantly rising in the pressure cooker, though we say that there is no change in the volume because the pressure cooker is sealed by its valve. This is the valve. Okay, so the pressure cooker is completely sealed and closed by the valve at the top, so there should be no passage of heat, and because there is no passage of heat, the volume cannot there would be no change of volume in this particular process. Why? Again, compression and expansion, these are the two processes which will be happening in thermodynamical system, and because of compression and expansion, pressure, volume, temperature, all these things get changed. We will going to study about compression and expansion too in detail once we will be studying about isothermal process and adiabatic in detail. Okay, but as of today, once the pressure cooker is sealed closed, that means you cannot change the volume. And if you put that pressure cooker on a flame, that means it's the air inside the pressure cooker, its temperature and pressure will going to rise, and because the pressure and temperature is rising, there will be a production of heat, and that heat will going to come out from the valve. The heat will going to come out because there is a lot of pressure, lot of temperature, so there will be only a slight amount of heat will be coming out from the valve at the top. So because that heat is coming out, there will be a little bit of change in the volume of the pressure cooker, or we say a little bit of change in the volume of the air inside the pressure cooker, but that change is actually negligible. Otherwise, in the case of pressure cooker, once it is sealed and closed, it is undergoing a isovolumic process. That means volumes remains constant. So the important thing that we learned in today's lecture is that there are four type of processes. There is also one more type of process, that is quasi-static process. The fifth process is QUASI, quasi-static process. Quasi-static process means, static means something which is at stationary, not changing, and quasi means hypothetical. Okay, ideal. Though this process is not in action, not in practicality, but we just say that it is basically a hypothetical construct. We just consider it. What basically happened in this particular type of a process, that all, for example, you have a gas inside this container. Okay, you have a gas inside this container, and all the parameter, pressure, volume, temperature will change, but at a very slow rate as compared to the surrounding. By surrounding I mean environment. There will be some pressure and temperature outside. So whatever the change in the parameter take place in this particular system will take place at a very slow rate, almost negligible in comparison to the surrounding. So because that rate of change is very slow, therefore we consider it negligible. Okay, so that's why it is a it is a hypothetical case. In quasi-static process, the thermal and the mechanical parameters are in equilibrium with the surrounding. When I say equilibrium with the surrounding, it remains same. Means the parameter of the gas inside this container remains same as the parameters are outside this container. If here the pressure is PVT, then the outside pressure, volume, temperature will be also PVT. So the change is at a very slow rate. That's why it is a hypothetical construct or an ideal case which we do not consider in our practice, which we do not see in practical life. So these four are the important processes which we'll be learning in detail in our next lecture. So thank you so much for watching the video. Thank you. Kamagani.